Hi, it's time for another math easy solution. To discuss further into calculus with parametric curves, and now go over an example on arc length and go over example 1. So make sure to watch my earlier videos on arc length to get the formula for that. And basically, let's go over this example, which states find the arc length of a unit circle if it is written in the parametric form x equals cosine t, y equals sine t, where t is between 0 and 2 pi. And this equation here, I've already gone over how to draw this in parametric form, and I did this in my earlier video, and I'll put the link in the description below. But now if we want the arc length, then basically what we get is a unit circle, or a circle with radius r. So to do this, well, to solve for the arc length, so recall from my earlier videos that the arc length is equal to integral from alpha to beta of the square root. Now we have dx over dt squared plus dy over dt squared, and then dt like that. But in our case, we have it from t is between 0 and 2 pi, so this equals to 0, and this equals to, well, 2 pi. That's a range. And now our dx over dt, or the derivative of the x variable right here, is going to be, well, derivative of cosine t, which is, recall, that's just, well, negative sine t, like that. And then y equals sine t, the derivative dy over dt is, well, dy over dt equals 2. Now that's just cosine t. The derivative of sine is just cosine t. So now what we could do is, well, we could throw these inside there, and then this negative one in there. So what we end up getting is, we get L is equal to the integral from 0 to 2 pi, and now we have a giant square root, and now we have a negative sine t all squared, plus now we have cosine t squared, and then dt. Now what we have here is just, well, this negative sine t squared is just positive sine t. So what we get is sine t squared, or I'll put the squared here, plus cosine squared t. This equals to, well, recall that this equals to 1. This is the recall trig identity here. Trig identity, and I have the proof in my earlier video. Identity, basically the sine squared plus cos squared is just 1. So this whole thing is just 1. So we could throw that back inside. So what we end up having is L is equal to the integral from 2 pi of square root 1, which is just 1. So we just have 1 here, or dt. We could even remove the 1. Let's just assume there's 1 there. So what we have now, the integral of that, integral of just 1 is just a constant. So then we have t, and we evaluate it from 0 to 2 pi, and then we can plug these inside. So we get, well, 2 pi minus 0 is just 2 pi, like that. And there is our answer. And in fact, this is as expected, and that's because it's a unit circle. And since it's a unit circle, well, recall that the circumference of a unit circle C is equal to, well, pi times the diameter, which is the same thing as writing, well, 2 times the radius pi to r, and where r is equal to 1 for a unit circle. Unit circle just means radius 1. Circle. Yeah, so if it's just 1, so we're just left with 2 pi is the circumference, or the total distance traveled around a circle. And if you were to draw this out, as I've done in my earlier video, so we have y, this is x, like that. The equation is, we just have a circle like that, where radius r equals to 1. That's this distance across here. And now if we had a point across here and we rotated it a full 2 pi radians, that's just a full 2 pi, then basically what we're doing is, what we're graphing the arc length is from this entire thing around, which is, it turns out to be, this whole distance, that's just 2 pi. So in other words, this circumference C is equal to, again, 2 pi r, which equals to 2 pi as expected, circumference, and exactly what our arc length is equal to. So this equals to L, like that. So yeah, that's what we have. And yeah, this is all for today. Hopefully you enjoyed this quick example on the arc length, how to use arc length formula in an example, and that's the unit circle. And I'll put the link in the description below for my earlier video on graphing this unit circle. Yeah, I'll put that below. I did another example on that earlier. So anyways, check that out. Anyways, thanks for watching. And like always, you can download these exact notes and link below. Thanks for watching. Stay tuned for another Math Easy solution.